Okay, Daniel, these problems are all using those patterns that we need to just know off by heart and learn. So the first one was the difference of perfect squares, sometimes known as DOPs. So when we have a square term minus a squared term, it always, if we have to factorize it, which is what they're asking you to do, is that one will always end up being the first bracket will be the first term plus the second term, and then the second bracket will be this. So up in this first example, this is like your first squared term. So that's like your a squared down here in the pattern. And this one, because we can write that as 36 is the same as saying 6 squared. So we could write this like that. Well, there's our two squared terms. So when we go to write the bracket, we write what the first value. So it doesn't matter if it's b minus 1, just write that. First time I'm going to add 6. Second time I'm going to minus 6. Now because these are like terms, you can add them together to simplify it. So that would be b plus 5. And this one will be b minus 7. So that's for this one. Okay, with the second one, we have to always look for a common factor. So if you look here, the common factor is 2, because I could write this term as 2 times m squared, and I could write this 32, it could be written as 2 times 16. So because the 2 is a common factor, both being pi, you can take it out the front, and you'll be left with, so we're left with m squared minus 16. Now we're back to one of like these DOPS questions, because we could write 16 as minus 4 squared. So if we have to factorize this bit now, we've got a squared term minus a squared term, so that's going to factorize down to m 1 time plus 4 and m minus 4. So there's, you have factorized that one. With this last problem, that was using the other patterns, the perfect squared rules. So we noticed when we did expanding and factorizing, we noticed that if we had a plus b squared, or you could write that as a plus b times a plus b, we noticed that when you expand those ones out, it's always the first term squared plus 2 of the terms times together plus the last term squared. So now we want to go backwards. We want to go from this format back to that format, or this one here. So what we're doing is we're looking at these expressions and seeing if it is this pattern. Now, if it is this pattern, the last term should be able to be written as a squared number, which it can be. It can be written as 5 squared. So we've done that. So that's the first step. So yeah, we're looking good. It's got a squared term and a square term. Now we want to check this middle term. Is this middle term 2 times, because see how the rule says 2 times the first one, which would be x, times the second one, which is 5. And if you check that, that is true, isn't it? Because 2x times 5 is 10x. So because it is, you now know that you can factorize this one as x. You can either say x plus 5, or we can write that more simplified as x plus 5 squared. Okay, so we have to remember all these patterns, and it's just a matter of memory work.